start with integer linear programming. Now, if you had gone through the example of the linear programming, there was one particular one I didn't go through: TV commercials, radio commercials, newspaper advertisement. I indicated I should watch it, and it's also, the video is also on the channel. If you had watched it, you would have known that the final values were decimals. And decimals are not good for TV commercials. If you are talking about the number of TV commercials that were made, you can't say that 1.8 TV commercials were made. You can say that 10 radio commercials were made because it is a whole number. It's an integer, a positive integer. And you can't say that 3.2 newspapers were made. Like we did an advert, and we did the advert into newspaper, and then the newspapers, there were 3.2 newspapers, newspaper adverts. It doesn't make sense because those things are not decimals. Those things are not decimals. Okay. Those things are actually supposed to be whole numbers, and that is an integer. An integer is a positive or a negative whole number. That's an integer. Write it down. It's a positive or a negative whole number. However, when it is a positive whole number, that is what we are talking about, because we are not talking about negativity because of the non-negativity constraint. Okay. So we are going to look at situations that are real. For example, employees, the number of employees is not decimals. Aircraft is not decimals. We cannot have 38.56 aircraft. We cannot have 400.18 vehicles. You can't have these. You can't. It's not possible. It's not possible. You know. So that is something you shouldn't do. However, sometimes what people do is that they round off. Okay, but it's very dangerous to round off, because if you round off, some certain things are big, so you can't just round off. I'll give you an example. Suppose you have something like 4.25 billion. Okay. 4.25 billion, doesn't matter which currency it is. And you want to round up to the nearest whole number. What will be the value? If you want to round this to the nearest whole number, what is the value?
That's 4 billion.
4 billion.
4 billion.
So what have you thrown away?
The point.
0.25.
250 million.
You know the problem when everybody tries to talk and nobody raises their hand. It keeps happening all the time. And sometimes we feel like, oh, it's normal. But when everybody knows that very answer, then it becomes mania. So courtesy, raise your hand. I call you. The others keep quiet. That's how it works. So if you run this, big mistake, because you are talking about only, yes, Victor.
I was about to say 250 million.
Exactly. So what have you done to that 250 million? What have you done? If you round up, what have you done?
You have actually removed it.
Good.
So
that word removed it means you have thrown it away.
Yes.
So if somebody says that, I'll give you 4.25 billion. And then the person says, you say that, okay, that's okay. Round it up to 4 billion. It means you have dashed the person $250,000. That is crazy. So rounding off has its own problems. That is why it's better to use an integer programming solution. And that's what we are going to do, integer. There are 3 of them in the world, 3 major ones. And the first one, okay, is, and in all of them, you're going to introduce a new constraint called integrality constraint. Remember that the non-negativity constraint for linear programming is always there. That non-negativity constraint where you say greater than or equal to 0. Okay. That means that you don't want to have any negativity. But this one is an integrality constraint where you indicate that we want it to be an integer. In Excel, you see this int. In Excel, you see bin. Bin means that it's binary. Anything that is binary is a whole number. 0 or 1, that is binary. That is a whole number. You can't have 0.4 and then 1.7. No, every binary is an integer. So we're going to look at integer programming situations. Very, very practical. Unlike the continuous variables, integers are whole numbers. Now, the three kinds of integers, or three types of integer programming problem. You have the pure integer. Okay, the pure integer. Now, the pure integer one, all the decision variables must be positive value or 0. They must be whole numbers. They must be integers. All of them, all of them, all of them. All of the x's are integers. So x1 is an integer. x2 is an integer, meaning they are positive whole. x3 is an integer. x4 is an integer. Whether they are 0 or they are 1, they must be whole numbers. That's pure. Pure. Now we have the 0, 1. 0, 1 means that the decision variables must be 0 or 1. So if you have a particular decision variable x1, x1 is either 0 or 1. If you have x2, x2 is either 0 or 1. Now, what does a 0 mean? 0 means that x1 is there. Sorry, x1 is not there. And 1 means that is there. I'll give you an example. Suppose you are a man and you entered your house, and then you said that if I should see another man, that is 0, because I'm expecting to see only my wife. If I should see my wife, that is 1. So the x1 variable, that is what to see, is either going to be a 0 or is going to be a 1. Now, Adrian Kumsin, Vance, which one are you expecting to see when you enter your house? Is it 0 or 1? Adrian Kumsin. This is how I get to know people are participating. Yeah, Adrian.
Yes, sir.
Yeah, which one?
0.
Are you married?
No.
No problem. You have a girl, don't you?
Yes.
So which one are you expecting to have, 0 or 1?
1.
Sorry? Did you say 1 or 1?
1.
Okay. Okay, why?
Because if I go home, I'll see her. Like I have to see her.
Good. So the human being you're expecting to see is a 1 because that should be your wife. That's it. Okay? And this is a typical example of a binary integer. Binary integers, each decision variable takes a value of the 1. 1 here means is there. 0 means is not there. It doesn't mean anything. It doesn't mean 1 is better than the other, but 1 means that the 10 is there. 0 means the 10 is not there. And then you have the last one, which is a mixture of all of them. Now, when I say mixtures, what I mean is that the decision variable x1 or x2, it can be a binary, or it can be a pure integer. That means pure whole number. And it can also be decimals, like normal one. Okay? Like decimals, continuous variables. Okay, so that's what we mean by mix. Everything. So that's a mixed integer model. In other words, there are some of the variables that are integers, even though some are not integers. Now, what I'm about to do is that I'm going to show you a couple of examples of all of this. And each one I show you, I'm expecting that you will later run the Excel by yourself and then do it. Okay. So let's try to look at examples of each one. Yours is to tell me whether it is pure or binary or mixed. Pure or binary or mixed. Some of them are easy, some of them are not easy. My computer is frozen. Can you guys hear me? I think it can.
Yes,
Yes.
please.
Yes, sir.
Yes, we can hear
Yes,
you.
sir.
Yes, sir, we can hear you.
Yes, sir, we can hear you.
Okay, all right. So let me clear this and then let's move on to the next. So let's take a very quick, sharp one. Agbala, owner of a shop, plans to expand by buying new machine presses and lathes. Each press bought will increase profit by 100 every day. Each lathe will increase profit by $150 or cedis. The number of machines Agbala can buy is limited. It's limited by the cost of the machines and also by the floor space. Now, below are the requirements. So you can see that Agbala, remember Agbala wants to expand the buying of a new press and a new lathe. So the decision variables are presses and lathes. Now, you might not know what a lathe is, you might know what a press is, but let's take it like a printing press, basically. Okay. Would that be an integer or it will not be an integer? Who can raise a hand and tell me? Printing press. Is it an integer or is it not an integer? Is it an integer or binary or is it not an integer? Printing press. So in this case, remember, you want to buy. Those are the things you want to buy. One of them is printing press. The other is a lathe. So your decision variables will be X1 and X2. Where this X1 will be the number of printing press you want to buy, and X2 will be the number of lathes you want to buy. Obviously, these two can never be decimals. And because they can never be decimals, these two are clearly integers. So it's a typical example of a pure integer. So if you want to write your objective function, how will you write it? If you look at it here, it says Agbala has a budget of 40,000 for buying the machines. So remember, you have a budget here, which is the purchase price. The purchase price is the 8,000 and then the 4,000. And the budget for that is 40,000. So in this case, the 40,000 becomes available. Okay. Then for this space, it has 200 square feet of floor space available. So again, these two will be on the left-hand side, the 15 and the 30, whereas the 200 is on the right-hand side. Agbala simply want to know how many of the machine to buy to maximize profit. Basic way of formulating this is that you're going to have your Z variable. Okay. And then with your Z max down, what you're going to do is to maximize. Now, what are the requirements? Go to the top, you see the profit margin. One is 100, the other is 150. Okay. So that's what would take your initial one. So you have 100x1 plus 150 x2. And now subject to, you can now make your subject to, and then you will have one being the floor space. So you have space constraint. And that space constraint will be 15x1 plus 30x2. Less than or equal to because of this available. And then on the right-hand side, you have the 200. The 200 being the available space. And then for the budget, so the next one will be the budget constraint, which will now be the 8,000 x1, because that's for the lease, the price. And then the other one becomes 4,000 x2. And the amount of money available to do all of that is 40,000. Okay. Now, the most important one is what I'm about to write. 40,000. You have to, of course, bring your non-negativity constraint, which is your X1 and X2. Good. This is called non-negativity constraint. But you have to bring the integrality constraint because these two items cannot be decimals. So you also have to indicate that after you've written greater than or equal to 0, you can add and integer. That's one way of indicating it. Or you can also do the X1 and X2 again, and then write equal to int. Okay, int referring to integer. So that's how you formulate it. Let me show you properly. I know this one is the easiest one, so that's why I'm not taking much of the time. So this is it. Okay. So the objective function, we know that already. This is the left-hand side of the 2, but the most important one is this. This last one. So you add a non-negativity constraint, and you also add the integrality constraint. If you don't add this integrality constraint, everything is wrong. This is an easy one I'm going through. Let's go to another one. Okay. Ligon cancer. This one is tough. This one is tough. This one is tough. So I want you to pay attention and soak yourself in. Somebody is worrying you back there, shouting, making noises. Soak yourself in. Have your pen and paper. Soak yourself in. Soak yourself in. I can't speak any more than that. Now, Legon Council must decide which of the 4 recreational facilities they want to build. The council wants to actually build a pool. They want to build a table tennis center. They want to build an athletic field, or they want to build a gymnasium. But they want to build them in such a way that they can maximize not profit, but they can maximize daily usage by the residents. So I'm about to show you the daily usage for each one. I will also show you the cost involved in building each one. I will also show you the land requirement for each project. So let's look at the data. This is the data. So what you see here, first, these are the recreational facilities. The first thing you see here is the expected usage. That is the number of people expected to use the swimming pool is 300. The number of people expected to use the tennis is 90. The number of people expected to use athletic field is 400, and the gymnasium is 5. Now, just based on this alone, which one do you think they would have gone for? Which one do you think they would have gone for? Harold.
Tennis center.
Why? Don't pick a number if you don't know why you are picking the number for. So let me give you time to think whilst I call others. Andrew.
They would go for the athletic field.
Why?
Expected number. It's higher as compared to the other facilities that they intend building.
It's higher in what?
The usage, the number of people per day.
Why?
Athletic field has 400 per day. As in, it would generate more income.
Exactly. You see, you got to speak. You got to speak. You know, you don't just say, you got to speak. But go back to the question. The question says that they want to build these things in such a way as to maximize daily usage. That's what it says. So if you want to maximize daily usage, you want to maximize the number of people who will use the thing. Okay. So that is why you have chosen that athletic field. Okay. So that is the first thing. No, if you were to go by that, you go for this. But don't forget that there are other requirements. One, let's look at the cost. If you were to go by the cost, which one would you actually go for? By the cost. Abdul Rahman,
Gymnastics.
you'd have gone for gymnastics. Okay, yeah.
Yes, sir.
All right. Who else? Some of you are here, some of you are not here. Dinah.
Tennis center, because
Why?
it has the cheapest cost.
Exactly. You'd have gone for table tennis center because it has the cheapest cost. The long tennis center. See, you guys have to think through a lot before you actually come here. And that will help you to, I told you, put everything beside and soak yourself in what we are doing. Now let's go to land requirement. If you are to go by this, which one will you go for? If you are to be based on land requirement, which one will you go for? If you don't have a reason, don't talk, Emanuela.
Still the tennis center because it requires less size of the land.
Okay, Salam.
Yes, sir. So I'll go for the tennis center because it
Okay.
requires less.
Victor. Aminu.
Yes, I'll go for the tennis center because
Sandra.
of the smaller land space.
Sandra.
So the tennis center.
If you have said tennis centers, lower your hands. If you have said that already, lower your hands. Once your hand is up, it tells me that you have another answer. That's why I'm calling those whose hands are up, and you're all repeating the same thing. Adrian.
Please, I wanted to. It can be athletic field, right? Because if you have a.
Why you say it can be? You are not sure. No. You are not sure. No. Okay.
No, it's a 7. Because if we have a land size and want to maximize the whole land, like want to use the whole area we have, then the 7 athletic would be the best.
Yeah, that's it. Thinking. We've not even come to the real question. Okay. You want to have a big land. You want to have a big land. How would you want to have a small land? I didn't tell you about costs involved in the land acquisition. Cost is already there. The cost, we handle the cost. Now somebody says, I want to give you a land. I'll give you 2 acres of land, or I will give you 7 acres of land. If we are Takunedu, we'll pay Abdul Rahman Sule.
Yes, sir.
Is that the answer you would have told the person that I want you to give me the small acres of land?
No. With regards to your question, I'll take swimming pool.
It's okay.
If you look at the ratio of
It's okay.
size
It's okay.
usage.
What ratio is he talking about?
Oh, so we're looking at the size of the land, you're saying the acres to its usage.
Please, forget about usage. I'm just giving you what you have here. I took each one by one, no, didn't I? When I was talking about usage, I didn't talk about the land. I didn't talk about the others. I said, based solely on land requirement, which one will you go? Or because you saw that the budget cost, but that budget was a cost, it wasn't a revenue. That is why
I made an error there. Apologies, yes.
Okay. So let's go here. You have been told that LC, the Legon Council, has 120,000 budget, and they have 12 acres of land available. So there's that kind of available land. They didn't say the word available, but you should know that it's available because the budget is always what is there. The budget is always what is available. But they have some clauses for you. There are some serious clauses. Clause number 1, because swimming pool and tennis must be built on the same portion of the land, only one of these 2 can be built. Only one of these 2 can be built. You have to think around that. Legon Council want to know which facility to build in order to maximize the expected daily usage by the residents. Question: what do you think are the decision variables? Let's go back here. What do you think are the decision variables? How would you write them if you are thinking, not if you are guessing or if you are picking the answer from someone? Irene.
So let X1 represents pool, X2 tennis, X3 athletic field, and X4 gymnasium.
You have tried, but I've always been telling you that never write your decision variables by just using what you see there to represent X1 equals to Kofi, X2 equals to Ajwa, S3, no. Or X1 equals to car, X2 equals to Ben, X2, no. Never define your decision variables like that. Decision variables must be properly defined all the time. So who will come up again? Victor.
Let X1 be equal to number of swimming pool facilities. X2 be equal to number of tennis center facilities. Then X3 be equal to number of athletic field facilities. Then X4 be equal to number of gymnasiums.
Okay. Whilst you have tried by bringing the unit of measurement, there is an issue with this. If you have an understanding of that. Now watch it. And again, if of course you know that we are doing integer programming problem. And if you know that, watch the first sentence. What does the first sentence tell you? First sentence. It tells you something. What does it tell you? What impression is that giving you? Benjamin.
So the impression is at least one of the facility must be built, which must decide which of the four facility to. So at least we are choosing from the four.
Okay. You have some idea. Not the fullest though, but you have some idea. You are not far from the kingdom of God. Who else?
Then, Doc, please, can I polish it? Maybe.
Okay, polish it.
Okay, one or two, choosing from the four, the one that will maximize the usage.
So what are you saying?
That means you are not building out the four.
So what is going to be the decision variable based on what you just said? Anyway, you have answered my question in terms of what does that give you the impression. Now, if you look at the thing very carefully, so you got to make a decision. For each one of them, you got to make a decision. What decision are you making for each one of them? Christopher.
So say X1 would be the decision to build a pool. X2, a decision to build a tennis center. X3, the decision to build an athletic field. And X4 will be the decision to build a gymnasium.
Nope. You've tried, but no. Gideon.
Yeah, I think X1 will be the decision to either build one of the recreational facilities, and X2 will be the decision not to build.
Oh, Koviedu. And what about X3? Oh, there's no X3. What's the idea? Oh, I really, the way you started, I thought you were going to crack it, honestly. Patrick. Patrick, increase your voice.
Hello, sir.
Mm-hmm.
So let X1, X2, X3, X4 be the type of recreational facility.
You are going to pick answer from somewhere. What you are saying is wrong.
Oh, no, I didn't pick it from anywhere. I'm just thinking.
But you can't put all of them together too. You can't put all of them. No, you can't put all of them together. We are picking them. Margaret.
So let X1 be construction of.
No, you picked it from somewhere. No, you don't get it. I need your understanding of that sentence than what you are picking for me. See, let me give you some kind of point. Whenever I'm teaching you, don't keep the slide with you. You are hurting yourself if you do that. Don't keep the slides with you. I deliberately decided to give it to you this time for a reason. Don't keep it with you. It doesn't help you to maximize or expand your mind. Tewo, Jacob.
Let X1 be the decision to build a pool on the acres, the acre to build a pool on. And X2 be the decision to build the tenant center on the acre. The same applies to the X3 and X4.
Hey, chief of staff. I like the way you started it. No. No, Kofi. Kobna. That one won't crack. Let's go to Redeemer. Last one, Redeemer.
Okay, sir. I have an idea. The decision variable will be like, let X1 be, whether we are building or not. I don't know how to phrase it. Because looking for a
The guy
decision,
started by the same thing. I don't know how to put it. What is that?
We like reading for it, we have to decide.
Master, you are writing it. So don't tell me you don't know how to put it. Put it the way you have to put it.
Okay, so let me try this. So let X1 be. Oh, so it's okay.
Hey, it's not easy to cross the Red Sea. All right. So let X1 be whether or not to build a swimming pool. X2 is whether or not to build a tennis center. X3 is whether or not to build an athletic field. And X4 is whether or not to build a gymnasium. You see, it is a construction of these facilities or not constructing these facilities. That is what you got to make a decision on. That is a decision variable. Irene, is your hand still up for a reason? That is what you got to make a decision on. Okay.
So I wanted to redeem myself. I was asking that, can it be, let X1 be at least?
No, you can't use at least. Because once you use at least, you are, no, you can't.
At least the decision to build.
But look at the English you are speaking, at least the decision to build. Okay, what is at least the decision to build? It's either you are building or you are not building. That's the whole thing. Either you're building or you're not building. So that is a decision. Okay. Now, in the slides, you probably, like I said, don't use the slides though. You see that I would have written construction of that because I've deliberately written that so that you tell me that, but when you tell me that, that is not the exact way. That is not an understandable way of putting it. You got to first of all know that based on this story, you will either choose to buy or you choose not to buy, given the constraint and the other conditions. Okay, let's move on. So those are the decision variables, whether or not to build, which is construct, or not to build. Now, let's go to so those are the decision variables. And remember, each one of them will be a binary because whether or not to build makes it a binary decision, okay? And that is a very important, okay? And I've put it here, that the project can have values of either one, that is when you select it to build, or 0 when you don't select to build it. Okay, we are maximizing something. So what is objective function? Using this table, which one is going to be the objective function? Using this table, which one will be the objective function? Objective function. Think small. Think small. William. Yeah, Benjamin.
Okay, so please, we use the expected usage to write the Zmax.
So what will it be?
So it's going to be Zm should be squared to.
Did you say Zm?
Z maximum, sorry. Should be squared to 3x1 plus.
Did you say 3x1?
Yes, please. Well, I'm thinking maybe from the swimming pool will be the one to build or not to build. So
And did you say
let's
3x1? That's what I'm asking.
300. No, sorry, 300x1.
Okay.
Plus 90x2 plus 400x3 plus 150x4.
Very good. That is it. Okay, so that is the objective function. This is the objective function. Now, in this question, looking at this table right here, how many constraints do we have? And what is the first constraint? How many constraints do we have? And what is the first one? How many constraints? Just looking at the table. Ben.
So please, we have two. That's the cost and then the land required.
Excellent. Okay, so we have the cost constraint and then we have the, remember in the story, you have been given something related to the cost, which is 120,000, and then the land, which is that. So what do you think is going to be the cost constraint? What do you think will be the cost constraint? Of course, you can get it from this table. How will you write a cost constraint? Learn from what Benjamin did some few minutes ago. Cost constraint. Don't shut yourself up, Joyce.
35,000 x1 plus 10,000 x2 plus 25,000 x3 plus 90,000 x4.
You are done. I didn't say you shouldn't be done. No, I'm asking whether you are done. No, that's not correct. Dinah.
Okay, so the cost will be 35,000 x1 plus 10,000 x2 plus 25,000 x3 plus 90,000 x4 greater or no, less or equal to 20,000 budget. I've gotten the budget amount 120,000. Yes,
So that's why I told you guys to be writing things down. You see, I had a book. I said you should have a book. Write the numbers all down. If you have a book and you have been writing some of the numbers down, it will help you to follow through what we are doing. Okay, but that's good. That's a very good way of sensing the cost constraint. And then, of course, the acre constraint or the land constraint. It will require you to add the 4x1, 2x2, 7x3, 3x4, less or equal to 12. So that is how the two constraints will have to be. Now, apart from these two, there was a constraint that was given, apart from these two constraints. And that constraint came from this sentence here. I want you to look at the sentence before we start learning something new. It says that because swimming pool and tennis must be built on the same piece of the land, only one can be built. Now, swimming pool is what value? X what? Swimming pool is what? Benjamin?
X1.
X1.
Okay. And what about the tennis? Harold?
X2.
So if I mute all of you, those who are shouting the answers, will you actually raise your hand? Okay. Now, so keep those variables in mind. It says because the two must be built on the same piece of the land parcel, only one can be built. What does that mean? Well, I know if I ask you, each one of you is going to be a bit of a headache. So I'm going to show you some ways of cracking this. This is called a contingency because the building of one requires that of the other, building of the other. So that's why it says that you have to use the same piece of land to do that. So this is called a contingency clause. Either you build a swimming pool, which is X1, or you build tennis, which is x2, but not both, because he said that either x1 or x2 can be built, but not both. Now the word can be built, what does that mean? If you can do something, it's different from if you must do something. So can, first of all, must carries which symbol? If I tell you that you must do it, what symbol is that? Ben?
Yeah, equal to.
Equal to, that is must. Okay, so either swimming pool or table tennis must be built. That word must be built means that x1 should be equal to x2. But then it says can be built, but not both. What does that mean? Can. And you're going to tell me why you chose that, Gideon.
It is only less or equal to one. We can only build one, but not the two.
You can only build one, but not the two. But you can also what?
You can also choose not to build.
Exactly. You almost forgot that part. Okay. So x1 is less than or equal to x2. Where the less than here means that, who can tell me? The less than here means what? If it is less than, it means x1 is what? Because you just said that x1 is less than or equal to x2, which is a can. So if it is less than, then it means that x1 is what? Remember, they can only take values of 0 or 1. Don't forget, we said that before. Now you got it. Victor.
If it's less than, then x1 is 0.
And what is x2?
X2 is 1.
And if it is equal to?
That means both of them are 0.
Hey, yeah. You are guessing. This is why I get to know that the person is guessing. Let's go to Emmanuel.
1. X1 is 1 and X2 is also 1.
Yeah, it's 1. It's 1. I thought he was going to crack it. Unfortunately, he disappointed me. Okay. All right. If it is equal to, okay, because he has already told you that built means that the thing must happen. Okay. Anyway, so that is how you analyze those conditions. The word or is actually plus. That's why we're using those plus in that case. Now let's go to another one. Let's go to another one. Suppose I'm going to build x1 and I'm going to build x2. Oh, it looks like I swapped this thing. Yeah, it looks like I swapped this thing. Let me go back here. Let me just go back here. Okay. So the word or is always add. Okay, or is always add. Okay, either or is a kind of a Venn diagram when you are always adding. So A or B is A plus B. Okay. But if I say A and B, that is A times B. So or is add. So if you add table tennis to swimming pool, then you have x1 or x2. If you choose can, we know that can is less than or equal to. If you building both, okay, so let me show you here. So if you are doing or, okay, or is plus. If you are building both, what? And then of course, according to the thing, you must have one in the end. If you are building both, then it means that these two, one of them cannot be built. And if one of them cannot be built, then it means one can be built. So I can say that swimming pool or tennis can be built. If I say can be built, this is what you have. We've already established that. But if that less than or equal to is the situation, it means that if you are building swimming pool, which is 1, it means that you are not building tennis, which is 0. And that will still satisfy this condition that you are seeing on the screen. But it can also mean that it can be 0. That is what this condition means. This condition means that you can choose also not to build both of them or either of them. And when you decide to not build either of them, this condition of less than or equal to 1 will still hold. That is can. But if you are building, or one of them must be built. If one of them must be built, then you must have equal to 1. Okay. And in that condition, x1 plus x2 must be equal to 1. Which means that in that situation, you got to identify which one has to be built. Of course, remember, this is a conditional condition. This is an extra condition. It doesn't mean that that's the value of x. So it means that if we find that the value of x1 is 0, then it's automatic that the value of x2 is 1 for this condition to hold, for the must build to hold. This must, this can, are symbols that you can use to run your conditional or contingency clause. There are several contingency clauses I can add here. Let me give you a couple of examples to appreciate this further. Okay. Let me give you one. Suppose it says that either swimming pool or tennis must be built, but not both. What constraint is that? I think we said it. Let me see whether you can still get it. What constraint is that? Table tennis, tennis center, or swimming pool must be built, but not both. Manuela.
X1 plus x2 equal to 1.
Okay, we know this already because we have just spoken about that, okay, already. Because what you are doing is that you are forcing them to choose. This is called a multiple choice constraint. We've said that. But let me give you some tricky ones here. Okay, let's look at this one. Okay, no, let's go back to the question. You already know that by actually starting this question, you already know that this thing is a binary programming model. Sorry, someone is really cooking something. It keeps entering into my nose and I don't really like it because the aroma is too good. Okay, so yes, so we already know that there must be the integrality constraint. Okay, but what kind of integrality constraint was there? There's obviously going to be the non-negativity constraint, which is x1, x2, x3, x4. All of these must be greater or equal to 0. This is an non-negativity constraint. But we've already established that this is a binary. Each x1, okay, and each x2, all the way up to each x4, can either be built or not be built. So at this stage, you can just add and integer. Actually, you can't even add an integer. What can you add? Who can guess? You can't add an integer. What can you add? Because we've already established that. You can't add an integer. Let me see what I can call somebody who has not spoken at all today, ever. Like someone who has never spoken in my life. Derek Diaba, are you here? Derek Diaba.
Yes, sir.
Good. I could hear your voice. You know, you've never spoken in my class.
I have. You might have forgotten, maybe.
Okay. Let's see what I can crack this. Derek. I'm trying to be sure that you are paying attention. Are you there, Derek?
Yes. Yes, Miss, I am.
Go ahead.
Yes, and an integer.
Derek.
My boss.
I caught you unaware, isn't it?
Yes, please.
I know. All right, you can go back to sleep. Salam.
So in binary.
And binary, that's it. Okay. And binary. If you have been following throughout this whole discussion, you would know that you have to make it end binary. Anyway, so that is, now that word end binary, you can either write it like that, or you can just write it like what I've shown here. Okay. Now, this binary constraint, this is another way of writing it. So instead of saying non-negativity and blah, blah, you can say equal to. Now, when you write this, do you sense clearly, when you write it like this, do you realize that the non-negativity is inside it? Do you see that? Do you see that the non-negativity is embedded in there? Can you tell me why that non-negativity is embedded in there? Can you explain? Can you raise your hand and explain to me why you say so? Salam.
Yes, sir. So the x1, x2, x3, x4 has to be greater or equal to 0. So we have the equal to 0, and then 1 is also greater than 0. So that fulfills the condition. 1 is greater than 0.
So why is it that it will be dangerous to write the non-negativity constraint? Why is it that it will be dangerous to just insert the non-negativity constraint? Just that. Richard.
Yes, so since we said it's binary, it's either 0 or 1. But if we say non-negativity, it means it can be greater than 1. So
good.
2, yes, sir.
Why is it dangerous to say an integer? But rather and binary, like we said before, or writing it like this. Why is it dangerous to say it's an integer? Adrian.
Because 0.5 is greater than 0.
Sorry?
I said we can have 0.5. 0.5, yes. And that would still be greater than 0.
So?
And then we don't want to have like decimals in here.
No, I didn't say that. I said and integer. Why should that not be used? That was my question. And integer. Bismarck.
Okay, it's similar to what my colleague before Adrian said. So because we are dealing with binary, it's either 0 or 1. If you bring in an integer, 2 is also an integer.
Exactly. 2 is also an integer. 5 is an integer. 100 is an integer. So once you say an integer, you are making the decision variable, which we already know they can only take a value of 0 or 1. You are making them take a value of 100, 200, anything. Any whole number, which is not correct. That's why you come out to do and integer. All right. Now let's look at some constraints that could have been added instead of the one we looked at. What are the constraints for the following? Suppose you have had exactly 2 of the 4 projects must be built as an extra constraint. What will it be? Exactly 2 of the 4 projects must be built. By the way, which symbol will you use here? Which symbol? Which symbol will separate the decision variables from some numbers? Which symbol will you use? In that sentence, there's a symbol driving. Emanuela.
We'll have to use an equal to.
Good. We have to use an equal to. Now, you are using an equal to now. Okay. Now, it says that And that word, oh, by the way, what guided you to use the equal to? 2 words.
Yes, you said exactly. That
Good.
means must, and then the word must over there.
Okay, so what should be on the right-hand side of the equal to? Is it 4 or 2? On the right-hand side, should it be 4 or 2? Emmanuel.
2.
2. Okay. In fact, even if you make it 4, you can never say 4 because the number 4 was not for the 4. It was for the project. It was for the project. So what should be on the left-hand side? That must equal to. What should be on the left-hand side? That must equal to the 2 on the right. It's a 4 project. What are the 4 projects? Yes, hello.
So x1 plus x2 plus x3 plus x4.
Very good. What does this mean? If you have this condition, what would that mean? In terms of swimming pool, gymnasium, all of that, what would that mean? You got to be incredibly smart here. What would that mean? If you have only that, Richard.
Yeah, so it means 2 of them can be 0.
And then?
And 2 of them will be 1.
Which means that you're using too many numbers. Talk to a project manager, which means that, what does that mean practically? Salam.
So it means 2 can be built, or 2 must be built.
And then?
And 2 not be built.
Exactly. Why are you guys saying pieces of the thing? It means that you have to build 2 projects. You have to build. I don't know which one, but you got to build. And make sure that you also don't build 2 of them. That's what this one means. Okay. There's a name for that, actually. Okay. There's a very beautiful name for that. Okay, suppose you have no more than 2 of the projects must be built. What would that be? No more than 2 of the projects must be built. No more than 2 of the projects must be built. What symbol are we looking at? No more than 2 of the project must be built. Daniel.
So the sign will be less than or equal to 2. So it's going to be x1 plus x2 plus x3 plus x4 less than or equal to 2.
Excellent. Very good. I agree with you. Let's move on. Okay. If swimming pool is very important, x1 is very important. Table tennis is also very important, but less important. What would that constraint mean? What would that constraint mean? First of all, in order for you to appreciate this, suppose I tell you that swimming pool and table tennis are equally important. What would that mean? How will you write that? How will you write that? Swimming pool and tennis are equally important. Victor.
That will mean that x1 will be equal to x2.
Exactly. X1 will be equal to x2. No question. So in this case, if I tell you that swimming pool is very important, it's not like the other one is not important though, but just that x2, which is the table tennis, is less important. What would that be? In that case, what would that be? Be careful. Somebody is sitting there. That's if you are thinking. What would that be? Christopher.
x1 will be greater or equal to x2.
Okay, that would not be correct. Dinah.
x1 is greater than x2.
Guys, watch it. I said swimming pool, x1 is very important. And tennis is less important. What would that be? Dinah, what did you say? Let me get that again.
I said x1 is greater than x2.
Okay, that's what you said. That's not correct. What did the other guy say first?
x1 is greater or equal to x2.
Greater or equal to x2. Gideon.
x1 is equal to 1 and x2 is 0.
Okay, you are saying things. Have you had lunch? Now, if x2 is less or equal to x1, what does that mean? X2 is less or equal to x1. How will you switch it? I'm just trying to see whether one of you is correct. I just want to see which one. One of you was correct. Who was that? Manuela.
This will mean that x1 is more important than x2.
Yeah, but what does that mean mathematically as well?
I'll have to give it another try.
Because
So
one
it
of
means
them,
that x1 is greater than or equal to x2.
exactly. Oh, come on! I have a friend in this room. That's what it means. Okay, so that condition is called a conditional constraint. That is what this condition is. That's what you see on the left side. Okay, but it's the same as somebody gave that answer. I think a guy. Okay, when I posed that question, one guy said greater than x1 is greater than or equal to, isn't it? One of you said that. One said it's greater. Yes. Yeah, one said that it's greater than, but I said that's wrong. But one said it's greater or equal to. Whoever said that. Okay, because you can switch this and get to that same answer. All right, so these are all sort of things. Now let's go at the last one. What if swimming pool should be built if and only if tennis must be built and vice versa? This one is easy. Swimming pool should be built if and only if tennis must be built and vice versa. What constraint is that? This is easy. It means that, yeah, Diana.
It's equal to.
It's equal to, that's it. The two of them are the same. S1, S2, they're all the same. All right, so this will become the final condition or facility that you would have gotten. This would have been, you can now complete this in Excel and solve it nicely. Okay, now this is another one. I'm not going to work this because my interest is on something very important today. There's another one where it says Nancy has $250,000 for investment. She wants to invest this thing into building, land, and bonds. Okay, building, lands, and bonds. Yours is to check carefully, and you will notice that some of them are carrying non-negativity, some are not carrying non-negativity alone, some are binary, some are not binary, some are mixed. You know. So first, let's look at building. What would you think a building will carry? All the three that we've looked at, what do you think building will carry? Will it just be normal non-negativity? Or it will be a binary? Or it will be an integer? Which one? Which one? Building. I think this one is cool. Remember, she has money, $250,000 available to invest. Okay, so building will surely be a pure one because you cannot split it. It cannot be decimals as well. And it's not going to be either you build or not to build. She's going to put this thing into investment. Okay, so that's the first one. Land. Land, what do you think land will be? Is it binary, an integer, or the continuous one? Jacob?
Binary.
You sure it's binary? No, it's not binary. Yes, Salam.
So I was going to say binary, but.
Oh, what makes land binary?
So, because you either buy or you don't.
No, this is an investment. He's going to invest. The thing is that he will invest in all of them. He didn't say that he has a choice to choose whether or not to. He's going to invest in all of this. Emanuela.
An integer.
Are you sure?
Yes.
I guess. No, because you can have a quarter plot. You can have half a land. Okay? Let's not mention. You just like you're not coming to your thought. You can have half a land. You can have a quarter plot of a land. So that's a clear indication that it is something that can be decimals. Okay? And so that will carry a normal non-negativity. It's not going to be an integer. It's going to be decimals. It's possible for it to be decimal. And then you look at bonds. Bonds is a pure integer. Okay? So you got to note some of these things. When you go and check, you will see it. Okay? So these two are pure integers. And I'm talking about the building, okay, and the bonds. The building, and the bond. Okay, so the bonds can even be a pure integer because it's a paper. But then obviously this one, the land is going to be decimals. That is a guaranteed. So you can see that x2 is positive. That's a mixed. That's a mixed. And normally, you won't have that mixed. Okay. Normally, you have that. You have the other ones. Okay. You won't have where you have some to be. You know, you can have a binary mixed with a mixed, but not an integer. Or you can have a binary with an integer. Okay. And I'm going to give you a couple of examples to end that. My interest in all of this is what we're about to do right now. Applications of linear programming, integer programming, application. There are 3 applications. I'll look at only one. Okay, the rest you can look at it from the book. Learn them yourself. Learn them yourself. Learn them yourself. I'm going to look at a fixed charge. Before I look at a fixed charge, I want you to pay attention here, please. Have you done economics, by the way? Guys, have you done economics? Have you done economics?
Not all of us.
Okay, good. But I thought they were teaching you economics, aren't they?
We just started learning it.
You started learning it, whatever it is, you are doing it. Have you done cost? Have you done cost?
Price.
Have you done costs in economics?
No, sir.
All right, okay. No
Yes,
problem.
yes, we have.
Somebody says no, somebody says yes. I don't even know what to believe. Students, they disgrace their lecturers. If the lecturer is here, would the lecturer say that he has taught you? Okay. So let's look at cost. Cost. There are 2 kinds of cost in life, or generally in economics. 2 kinds of cost. One cost is fixed cost. The other cost is variable cost. Do you remember the difference between the 2? Do you remember the difference? Who can tell me the difference? Benjamin.
So the fixed costs are costs that are fixed, so plant and then maybe rent. But the variable costs are costs that changes in the long run or due to time.
No, you haven't really explained the thing. You first of all don't use a word to explain the word. That fixed costs are costs that are fixed. First of all, that's not how you do. What is the difference between a fixed cost and variable cost? Basic. Gideon.
So example is,
don't give me examples yet. Tell me what it is first.
So fixed costs are payments over time, like cost over time. Particular cost that you are always incurring over time, and the variable cost changes over time.
It changes over time.
Yes.
That's how you guys were taught. Eh? What if there is no overtime? There's at a time. What if there's no overtime? There's at a time.
So fixed don't change, variable change.
Change with what? That's what I'm interested in. Doesn't change with what? Change with what? Okay, let's go to Harold.
Okay, so first of all, the fixed cost actually expenses that remain in the same business, whilst the variable costs are the expenses that will be variably not associated to the business itself. It keeps on changing.
Okay, hold on. Let's go to Bismarck. Okay.
Because these costs are costs that are constant regardless of the levels of production.
Now listen to the guy. He's now making the point. Repeat that.
So fixed costs are costs that are constant, whether production increases or decreases. But variable cost increases as production increases.
Exactly, guys. This is what we mean. Let's start with variable. Variable costs are changing with production. When production is 0, that cost is 0. Okay? You have not produced. Producing here is kill. Producing here is skill. If production is 0, that cost is also 0. As you are increasing production, you see production is increasing from 5, it's going to 10, it's going to 20. What are you doing to production? Production is going up. Now, because of that, cost is also going up. It moves from 10, it moves to 30, it goes to 60. That is variable cost. That is variable cost. But at that point in time, let's say fixed cost here is 20 here. Okay, let me put a different color here. Let's say that you have a fixed cost. This cost here is 20 here. That's fixed cost. Why? Because even when production is increasing, the cost is still 20. When you increase production to 10, cost is still 20. When you increase production to 20, cost is still 20. When you move production to 50, cost is still 20. When you went to 100, cost is still. So fixed cost is cost that is already incurred. It doesn't change with the level of production. Please, do you get it? If you don't get it, raise your hand before we move on. This is fundamental to what we're about to do. That fixed cost is what we call here in integer programming fixed charge. Fixed charge. Fixed charge. Fixed charge. Fixed charge. Keep it that. You're about to do something known as a fixed charge. Another thing I want you to know before we go on, okay? Profit is defined as what minus what? Who can quickly tell me? Profit is defined as what minus what? What minus what? Profit. This one, I want somebody who hasn't spoken today, not those who have spoken. Profit is what minus what? Will pay late in kafana will. Comfort. Charles.
Yes, sir. Profit is defined as selling price minus cost price.
Yo, thank you. Now let's get a little bit economics. That's the old definition of cost. When it's a selling price minus cost price. Remove the price. Remove the word price and give me a better mod.
Sir, please, revenue minus cost.
Good, that's all I want.
Minus total
So
cost.
profit is total revenue minus your total cost. Follow me here. Follow me here. Write everything. Write everything. Okay. Now, what is the total revenue? Total revenue is what times what? Raise your hand and tell me. Total revenue is what times what? You know that guy who told me that is the sales. What is total revenue? Godfred. Godfred, the Wusu answer.
So it's price per unit times the quantity.
So it's price times quantity. Let's keep that here. Price times quantity. Okay. Price times quantity. Keep it in mind. Price times quantity. Okay, good. Now we know that the total cost is already the fixed cost, okay, plus the variable cost. Hold on to this. That's the total cost. It's already fixed cost plus the variable cost. Now, which one of them will have quantity in it? The fixed cost or the variable cost? Which one will have quantity in it? Which one of them two will have quantity in it? Is it a fixed cost or the variable cost? Evans.
The variable cost.
Fantastic. So now, if I should represent the quantity by X, okay, then the total revenue will be the price and the X. And then the fixed cost is going to be fixed. So let's say constant K. And then the variable cost will be a price also with the X. Keep that in mind. Keep this in mind. If you understand this, you are about to shake your own foundation. Are you ready? You will get this thing. And once you know this thing, you can score 25 over 25 because it's the easiest you can actually do. Write this down. Keep it in your mind. Comfort, is your hand still up for a reason?
Sir, sorry, it's the old one.
All right. So now let's move on and look at a practical application of a fixed charge problem drawn on the principles of linear programming. The word fixed charge, I've already told you, fixed charge actually is standing for the fixed cost. Let's take a typical practical situation to appreciate this whole unique application of integer program. Tema Textiles Limited manufactures 3 types of clothing: shirts, shorts, pants, the manufacturer of each clothing type needs the company to have a suitable machinery available. Have a suitable machinery available. Without the machinery, no manufacturer of any clothing type. The machinery needed to produce each clothing type, that machinery must be rented at the following rate. The fact that they are being rented here makes it what? You can tell me. The fact that they are being rented here makes it what?
Variable.
Please, you see, those who don't know, they are the ones who shout the answers. They are the ones who wrongly shout the answers. I've told you, raise your hand, then I'll call you. Jephthah.
Fixed cost.
Jephthah, your voice is far.
Fixed cost.
Fixed cost, that's it, okay? So that rented is a fixed cost. That rented is a fixed cost, okay? Because normally when you go and rent a building, you pay that sort of thing we call deposit for 2 years. Whether you stay in the house or you don't stay in the house, you have incurred that cost. If you go and rent a shop and you pay for 2 years, whether you sell the goods or you don't sell the goods, that cost has already been incurred. It's fixed. It's a fixed charge. It's a fixed charge. It's a fixed charge. Now listen. I'm going to produce shorts, pants, shirts. I'm going to produce, whether I produce them or not, I am renting them a shirt machinery for 20 cedis. I'm renting a short machinery for 150. I'm renting a pants machinery for 100. I am incurring this cost. And I need these things before I can even start business. I need them. So they are already fixed, whether I buy, I sell or not. So keep that in mind. Manufacturing also requires another requirement, amount of cloth and labor. So it means that you are going to get some resources that you need to be able to do your manufacturing. And what are they? They are cloth. You need cloth and you need labor. Well, let's go down and look at it. Okay. So in terms of labor, that's what you need. So if you want to actually produce shirts, you need 3 hours of labor. If you want to produce shorts, you need 2 hours of labor. If you want to produce pants, you need 6 hours of labor. What about the cloth in yards? If you want to produce shirt, you need 4 shorts, you need 3 cloths, square yards. Pants, you need 4 square yards. These are the resources. You know that. Now let's move on. Let's go up. Every week, 150 hours of labor and 160 square yards of cloth are available. That should tell you that these things will go to the right-hand side of the equation. Now we come to the variable unit cost. You see, that tells you that they've already given you the fixed cost. So now the variable unit cost and the selling price for each type of clothes are shown below. Now let's look at it. So this is a variable cost for producing shirts. This is variable cost. The 4 is variable cost for producing shorts. At the same time, if you incur this variable cost, the price associated with it is 8. For each one of them, you see that the price will be more than the variable cost you have incurred. Of course, that's what normally business people do. They top up whatever they've incurred, they top up. So if you incur a variable cost of 8 for pants, okay, the sales price is 15. So if I only know how many pants I'm producing, I will multiply that number of pants I'm producing by the 15, and I will know the sales, what you call the total revenue. I will know the sales from pants alone. A fixed charge question will always require you to formulate and formulate alone. Don't solve. Formulate and formulate alone. Don't solve. Here's a question. Formulate an integer programming problem whose solution will maximize the weekly profit. You're not supposed to solve it. It's a formulation alone that will give you the 25 marks. That means that a lot of thinking must go into the formulation. Well, first of all, you've been told that it's an integer programming problem. So now you got to think about writing your decision variable. What do you think is going to be the decision variable? Who can take a first quick guess? What do you think is going to be the decision variable? Don't think too much, because I said you are thinking now, some of you are thinking too much. So the first decision variable is to know the number of shirts you want to produce. So you can say that let X1 be the number of shirts to produce. X2 be the number of shorts to produce. And then pan to be the number of pants to produce. So you have X1, X2, X3. I'll show you. These are the baby ones, X1, X2, X3. Okay, where you are talking about the number of. Now, in your mind, what kind of integer do you think this is going to be? We know that's going to be integer. What kind of integer do you think it will be? In your mind. It didn't say you have to choose between them. Always know. Victor.
To be a pure integer.
It will be a pure integer. It will never be a mixed anything. It will be a pure integer because you can't have half of shirt or a quarter of shorts. It's a pure integer. So these are the decision variables. But watch something very carefully. In the thing, you also have to make another decision. So there's another group of decision variables. How do we know that? You cannot even think about producing these shirts, short, and this is so fun. I was writing shirt for all of them. Okay. You can't produce these things unless you already have the machinery needed to produce them available. The machinery is not even there. You don't even think about it. So you got to make a decision whether you have to go for the machinery. But if you're also going for the machinery, you got to be aware that you're going to produce. So there is that kind of another thing you got to decide on here. And this is how fixed charge situations are. There's another kind of decision to make. Okay, and that is the machinery. Now, watch it. The machinery is different. We all only have a machinery, a shirt machinery, a machinery for shirt. We also have a machinery for shorts and a machinery for pants. They are different machineries. So we can therefore say that we have got to represent each of these machinery because you got to make a decision whether we want to also rent the machinery. But watch it, this decision is not going to be the number of machinery. It's rather going to be whether or not you will rent a shirt machinery. Whether or not you will rent a shirt machinery. If you are going to rent a shirt machinery, then you already know that you are going to do what? Anton. If you are going to rent a shirt machinery, then you already know that you are going to do what? You know you are going to do what? Comfort.
So you know you're going to spend 200 cedis per week.
Yeah, but more importantly, you know you're going to do what, Dinah?
Produce shirts.
Exactly. If you're not going to produce shirts, why are you going to rent shirt machinery? So it means that the production of shirt also depends on getting the machinery. In other words, the acquisition of machinery itself is contingent on whether or not you are going to produce it. So these machinery types are either going to be there or not there. So we can have another kind of decision variables, which is Y1, Y2, and Y3, where the Y1 is going to be there if you are going to what? Produce shirts. That's it. If you're going to produce shirts, then Y1 is going to be there. That's the there no is what I'm calling it 1. But Y1 is going to be 0 if what? Who can tell me? Now, if you know, if you're going to produce shirt is X1, right? Okay. So what I just wrote above is when shirt is positive. Okay, it's positive. If I'm going to produce shirt, that is when Y1 is needed. Now, what do you think the next one will be? Y1 is going to be 0 if what? If X1 is what? If X1 what? Think about the symbol as well. When you have, if Y1 will be 0 if X1 what? Salam.
If X1 is 0.
Exactly. If X1 is 0. If X1 is 0, then I don't even need Y1. So Y1 becomes 0. And if X1 is positive, then Y1 is going to be 1. It's going to be there. The same thing with Y2. Y2 is either going to be there, that is 1, if X2 is positive. And Y2 is going to be 0 if X2 is 0. I want you to understand that that 0 means that I'm not even going to produce shorts. I'm not going to produce shorts. That is why X2 here is 0. And if X2 here is 0, then why do I even need shorts machinery? Then it means that. So Y2, Y1, Y3, they are all binaries. Whereas these ones are all integers. This is the most important thing. Once you understand this, the rest is easy peasy. So if you have a question, you can ask. So let me show you something. Yeah. All that I said has been done. The decision variables, I've mentioned it. Then I indicated that the cost of renting depends only on the type of machinery, on the cloth, not on the amount. So you don't need to talk about Y1 being the number of, no. Y1 is rather going to be 1 or 0. It's not going to be the amount of or the number of. So that point is said. So Y1 is going to be 1 if you are going to produce shirts at all. Otherwise, Y1, you don't need it. It's going to be 0. Y2 is going to be 1 if the shorts are going to be produced. Otherwise, you don't need it. And then the same thing with the Y3. So now we are going to substitute them into the equation. So keep this few small mass in mind. Let me explain it to you. It's a very simple thing. This one says that if Xj, where the J can be 1, 2, or 3. So if I'm producing any cloth here, that is it. That's why it is greater than 0. Greater than 0 here means that I am producing it. That's why it's not greater or equal to 0. But greater than 0 means I'm producing. So if I am producing, then this Y1, this Y will have to be 1. I've said it again. If I am not producing it, then I don't need the machinery for it. So all that we wrote up, this is a way to reflect it here. Now, let's get into the nitty-gritties. So that principle is very, very important. So we are going to now formulate the objective function. And what is objective function? The objective function requires us to have total revenue minus total cost. Okay. And if you look at the table that was given to you, that's how it is always. If you look at the table that was given to you, some things related to cost were given. Some things related to revenue was given. Okay. So now we are going to generate our total profit. Okay. I call profit with a pad. Let's call profit as a pad. IRI. So profit is the total revenue minus the total cost. And the total revenue is the price times quantity. So what is the price for shirt? What is the price for shirt? What is the value? What is the price for shirt?
6.
6.
12.
12. Yes, it's supposed to be 12 rather. So, but we don't know the number of shirts you are going to produce. So you have to add that price for shirt, multiply by the X1. Then you add the price for shorts, also multiply by the 8. Okay. Shorts is X2. Then you do the same thing for the pants. Okay. The price you're going to get is 15, multiplied by the number of pants. That's the first one. That would have been the total revenue. Then you subtract the total cost. But the total cost, let's deal with the variable cost first. Where are the variable costs? They are all here. So those variable costs, you will have, normally you would have had fixed cost first, but I want to do variable cost first. So that is 6, X1. It's variable, which means it depends on X. Okay. Then minus 4, X2. Then minus 8, X2. And now let's subtract the fixed cost. Now let's look at the fixed cost. The fixed cost was given. But remember that the fixed cost was not just a single number. If you look at here, we were told that the fixed cost for shirt is 200. The fixed cost for short is 150. And then for pants is 100. You can't just write these numbers. Okay, because these numbers are attached to it, whether you are getting the machinery or not. You only incur 200 if you are getting a shirt machinery. And the shirt machinery is what we defined as Y1. The short machinery is what we defined as Y2. The pant machinery is what we defined as Y3. So even though I'm going to write these costs, I need to attach the Y's to them. So you have 200, and then you attach the Y1. Then you have the 150, you attach the Y2. Then you have the 100, then you attach the Y3. This is objective function. Finished. But you have to simplify them because there are some like terms. So who can tell me the final answer for the objective function? Say it and let me write here. Who can walk me through? You can raise your hand and walk me through. Stay on this course. Stay on the course. Some of you start this and getting to the end, you start stepping out of the room. I'll take a roll call. Okay. People who start, okay, the number was larger, all of a sudden it's dwindling. When it is dwindling like that, I know those who are going to fail the course. Yes, Harold.
Okay. So Z max is equal to 6x1 plus 4x2 plus 7x3 minus 200y1 minus 150y2 minus 100y3.
Good, good. So this is how you have to indicate the objective function. If you can do that, this alone is 7 marks. Okay. This is it. All he did is that he simplified it. 12x1 minus 6x1 is 6x1. 8x2 minus 4x2 is 4x2. That's how he got that. And then 15 minus 8 will give you 7. If you have a pen and a paper with you, you will enjoy what we are doing. You will pay attention. You will formulate. But if you don't have a pen and a paper with you, you will not. So this is objective function. Take note of that. Now let's go to the constraint. How many constraints do we have? By the way, this is objective function. Okay, yeah. All of this that we did, that's it here. Okay. Constraints. How many constraints do we have? We have two. The first one is labor constraint. The other one is plot constraint. Who can quickly give me the labor constraint? Labor constraint. Yeah, Dana.
150 hours.
Did you say 150? I'm formulating the labor constraint. Patrick.
The labor will have 3x1
3x1
plus 2x2
plus 2x2
plus 6x3
plus 6x3
less than or equal to 150.
less than or equal to 150. That's it. That was the labor. The 150 was the available labor. What other constraint do we need to write? Harold.
So that's Claude.
Give it to me.
Okay, so we have 4x1 plus 3x2 plus 4x3 less than or equal to.
Good. I like the way you said you're coming. So don't worry, I'll go back here for you to see it yourself.
Right. That is 160.
Very good. 160. Okay.
Thank you.
So that was in the preamble. So that becomes 160. Now, at this stage, there are a few more constraints you have to add. What other constraint do you need to add? We already know them. What constraint do we need to bring? We already know that the x's are integers, isn't it? So the x1, or let's say xj, okay, xj is greater or equal to 0, okay, and integer. The x's are integers. The yj's, they are not equal to, okay, they are either 0 or 1. Okay, the yj's are actually going to be 0 or 1, but the xj's are pure integers. So these constraints are also needed. But, oh, by the way, I hope you understand this one. Okay? But let me show you this constraint first before. So this was a constraint we wrote. Okay? That was a labor, and then this last constraint is what we just did. But there's a problem. There's a problem. Tell all those who have left the Zoom to join back the Zoom. Okay? There's a problem. The problem is that if I try and solve this thing in Excel, and I did, okay, there is a problem. The whole formulation is not right. And this is the result. Tell me the problem with this result. There's a huge problem with the result. Look at the blue result, and you will know the problem. Look at the problem. Look at the problem. Remember the constraints we wrote. Look at the problem. Who has it? Okay, we got a winner. Emmanuel.
Okay, we agreed that if x2 or sorry, if x1 or x3 is greater than 0, then y1 or y3 should not be equal to 0.
So
having x2 equal to y1 equal to y2 equal to y3 equal to 0 makes it untrue.
All right. So once you have x1 being positive, then y1 must be positive. So to say that y1 is 0 is not correct. That's what he's saying. And I agree with him. I agree with him. So why is that so? The reason is because of this formulation. You see, anytime you formulate a linear programming problem and you have a linear programming, normally you have x's at the top. And now, for the first time, you have y's as well. The x's are in the constraint, as you can see here, but the y's are not in the constraint. The y's are not there. The y's are not in any of the constraint. Look at this constraint, it has x1. Look at this constraint, it has x1. Now, where are the y's? None of these constraints have got the y's connected to the x's. There is no connection between x and y. But you already said that. You said, oh, I didn't say, you said that anytime you are producing a clothing, okay, anytime you are producing a clothing, you will by all means will have incurred. So there's a connection. There is a connection. There is a link. There is a link between the machinery type and the clothing type. Please, are you with me? There's a connection. There's a connection between the machinery type and the clothing type. And that connection should have been brought into the constraint here, but it was not brought. So we are going to introduce a very powerful principle to do that connection. Please pay attention. We are coming to do a quick brain work. Then after that, we'll do a smart move. So here's the rule. The rule we know already, that anytime I'm producing the shirt, I am incurring a cost, a machinery cost. This rule must hold. So there must be a way to modify the model. And how do you do that modification? We can use this trick. And this is a trick. It's a very powerful trick. It's a very powerful trick. Let me give it a trick. Let me give it a trick. Don't be scared, okay? I'm going to introduce a certain value, M1, M2, M3, that are constant, that will connect the two. Let me write one for you to understand. I'm going to say that X1 is less than or equal to M1 and then Y1. And this trick will always be used. Let me explain well and you will appreciate it. In fact, let me write it on the top. Okay. X1 is less than or equal to M1, Y1. Let's try to understand. What is Y1 here? What is Y1? What is Y1? Quickly. What's Y1? Okay, Y1 is shirt machinery. Okay. X1 is shirt. M1 here means that if M1, so let's assume we are saying that X1 is less than or equal to M1. Now, if M1 is 1, what does that mean regarding the relationship between X1 and Y1? If M1 is 1, if M1 is 1, what it means is that Y1 is the same as X1. Oh, sorry, let me put it better way. If M1 is 1, then it means that whatever is on the right-hand side becomes Y1. So it means that X1 is less than or equal to Y1. It means that whatever the value of Y1 is, and we know that Y1 can be 0, isn't it? Or 1, isn't it? We know that this Y1 can be 0 or 1. Okay, so if M1 is 0, if M1 is 1, sorry, if M1 is 1, then it means that X1 can either be what Y1 is. That's what it means. It means that the maximum value, that's what it means. It means that the maximum value that X1 can take is what? You can tell me. The maximum value, if M1 is 1, if M1 is 1, if M1 is 1, then the maximum value that X1 can take is what? We are talking about the equality part, not the less than part. The maximum value that X1 can take is what? I need someone who has in this book. This one is so easy. Isaac.
1.
1. And what is the minimum value that it can take? What is the minimum value that it can take? If M1 is 1, What's the minimum value x1 can take? Is 0. Okay, let's move on. 0. Okay. So what this means is that what then is M1 doing? So M1 then refers to the maximum value that x1 can take. Watch it. The maximum value that x1 can take. That is M1. That is a trick. So we can use that principle. So M1 is nothing more than one of the x1s. So it's nothing more than one of the x1s, but it is the highest of the x1s. That's all. So let's go and check. How do we get this M1? To get the M1, you need to go to the constraints. And for each constraint, look at each constraint. We have these 2 constraints. For each constraint, we just delete this. Okay, so that you appreciate it. Because remember that M1 is what we are looking for. And M1 is the maximum value that x1 can take. M1 is the maximum value that x1 can take. So if I want to know M1, all I need to do is come to this constraint here and this constraint here, and then solve for the maximum value of x1. Guys, this is an equation of a line, if you look at it carefully. So what you have to do is that to get M1, watch me. To get M1, I'm going to do that here. To get M1, you do the other one. Follow me. This is the most important one. To get M1, question. This is what you should do. To get M1, it means that we are dealing with x1. When we are going to get M2, we have to deal with x2. When we are going to get M3, we have to deal with x3. All right, okay. So now to get M1, come to this constraint, each one of the constraints. Come to this first constraint, and then make x2 and x3 0, because you are looking for x1. Make x2 0. Make x3 0. Because you are looking for x1. But not just x1, you are looking for the maximum value of x1. So it means that the less than or equal to should be changed to what? If you are looking for the maximum value of x1, then the less than or equal to should be changed to what? Let's say it. Salam.
Equal to.
Equal to. This is how we learn in linear programming. Okay. You set it up to the equal to. That's on the line. Okay, to be equal to. So now we are going to have 3x1 equal to 150. We are looking for the maximum value of x1. So that means that x1 is going to be equal to what? 150 minus 150 divided by 3. What is it? What is that? That is 50. Right?
Yes.
That is 50.
Yes.
So you now have 50. But that is for the first constraint. That's for the labor constraint. We do the same thing for the cloth constraint. So if the constraint are 6, you do the same thing for each one of them. So we go to the cloth constraint. Now we want to set the x2 and the x3 to 0 and find the maximum value of x1. And to do that, we're going to have 4x1 equal to 160. Okay, which means that x1 is what? 40.
40.
Okay, so now the question is that which of them two do you have to take? Because the first one, x1 gave you 50. The second one, x1 gave you 40. And I know what you will say. Which one would you have taken? And I know what you will say, by the way. Which one will you take? Salam.
Say 50.
Diana, which one will you take?
40.
40. Diana, were you the one who said 40? Or you were guessing?
No, please, I wasn't the one who said 40.
Who said 40? Who said 40? That person is guessing. Otherwise, I'm going to ask you why you said 40.
Yeah.
Raise your hand and let me see you. The person will say. All right, the person is scared. The person was doing lottery. Okay, so it's supposed to be 40. Why? The reason is because if you take the 50 and drop it into each constraint, and you take the 40 and drop it also into each constraint, you will notice that the 40 will satisfy both constraints than the 50. So you always take the lower of the two or of the three or whichever one it is. Let's take an example. If you take the 50 and you set the 50 into the first constraint, okay, it will be 3 times 50. And 3 times 50 is actually 150, which satisfies the first constraint. But drop it into the second constraint, it will be 4 times 50. And 4 times 50 is 200, which does not satisfy the second constraint because the second constraint says that it is 160. But when you take the x1 equals to 40, you drop that into the first constraint, it will be 3 times 40. Forget about this one, they are already 0. 3 times 40, 3 times 40 is 120. And 120 is actually less than the 150, satisfied. Take the second constraint. You take this 40, you drop it also into the 4 times the x1. That is 4 times 40, which is 160. And the 160 is actually true here. And so the 40 satisfied both. Salom. Your hand is up, Salom. Diana.
Yes, sir. So the statement M1 is the maximum value of X, is the maximum value that X can take. You use that only when you are dealing with the signs as greater than, equal to, or less than equal to. Is that the only place you use it to determine whether to go equal to?
No, the equal to here is because we are dealing with the less than or equal to. Are you talking about what if it is greater than or equal to?
So the statement for M1 is the maximum value that X1 can take.
Yes, I use the maximum because we are dealing with less than or equal to. If you are dealing with greater than, it will be the minimum.
Okay. So the definition of the M1 changes depending on the sign.
Yeah, because as you can see, I'm even talking about M1, but there's also M2, isn't it?
Yes, sir.
So the M1 is in connection with this very example. And I wanted to use MI, but it will confuse you guys. So that's why I decided that let me not complicate it. Okay. Otherwise, you're going to have MI, MJ, MW. Then somebody say, this thing sounds Hebrew. Okay. So M1 is the highest value that X1 can have. And therefore, after you've done that, you have to take the value, assume that the others are what? 0. Once you assume that the others are 0, then you find your X1s in this case. And please remember, if the constraints are 4, you have to put it into each constraint. And at the end of the day, you are going to take the lowest one. Even though that lowest one is going to represent the highest of the X's, you still have to take the lowest. I've tried it. You can try it yourself. Okay? And whichever big, you see, because of the word maximum, some of you were tempted to say that let's take the 50, but the 50 is wrong. Because when you put it into the equations, it will not satisfy some of the equations. But when you take the lowest one, it will always satisfy some of the equations. You can do the same thing for X2. Okay, let's try the X2. Let's try the X2. Okay, so when we are doing the X2, it means that we have to assume that X1 and X3 are 0, isn't it? Okay, so we are starting the X2. So, hold on. So we have to assume that X1 here is 0, X3 is 0, X1 here is 0, X3 is 0. By the way, you have to write all of them and work it out. Okay. So you start by saying that what is the value of M2? Okay. Then you say that if X1 and X3 are 0, then from equation, whatever, let's say equation 1, we are going to have 2, then we are going to have 2x2 equals to 150, right? And that will mean that x2 is what? Who can tell me? x2 is what? Salam.
75.
Now, that's for the first equation. Okay? It also means that for the second equation, we are going to have 3x2 equal to 160, which means that x2 there is what? X2 there will be what? Abdurrahman.
53.33.
Good. You get 53.33. Don't worry about the decimalism. Okay. So approximately 53. Okay, now, because the constraints are just 2, we are done with the 2. Now the question becomes, which one do you select? Who can tell me which one do you go for? 75 or 53? I hope nobody will disappoint. 75 or 53. Okay, good. So that's it. So now you can say that M2 is now finally equal to what? 53. And then you can do for 3. When you're doing for 3, you assume that the rest are 0. Let me show you. All of this, I've done it here. Okay, I've done each one of them here. All these things, I've done each one of them. Substituting, which one do you go? You choose the smaller one, reason, and all of that. We do it all of it. Now, once you are done, and you now have the value of the M1, M2, and then the M3, and then the M4, whichever one it is. Now, you rewrite this whole equation. You rewrite it all again. And now, instead of the M1, you write your 40. Instead of your M2, you write your 53. And instead of your M3, you write your 25. And so your final equation becomes something like this. So that's all you did, and then resubstituted it. If you go and work this one, this is a result you get. By the way, you can adjust it, you can rearrange them nicely like this. Then if you work this one, you will see that x3 will be 25, y3 will be 1. So it means that y1 and y2 were all 0. And that is why x1 and x2 were all 0. It means that the only thing this company has to produce is pants. Produce 25 pants. And that will give you the maximum profit of 75. This is how you solve. So if you make shirts at all, no matter how many shirts you make, you will have to pay a fixed charge of 200 to rent the shirt machine, okay, which is useless. Okay. No matter how many you make, okay, well, even if you don't make, you still have to incur. But when you do for the other ones, you can work it. I decided to work this thing in Excel. I've shown it here. Okay. If you work it out, you will see clearly that you're going to get that 75 as the final Z value. So I have a one in your slides for you to work on. Okay, I have one in your slides, and you should try your hands on, and it will help you in solving it. Your ability to work. If you want me to give you some more examples to work on your own, the most important thing is that once you have found the constraint, you create that equation which is the M1, okay, MI equation, this one. This equation, you just have to create that equation. And then tell yourself that in order to get the MJ, all I have to do is to assume that particular MJ is 0 in each of the constraints and solve for the one I'm looking for. Assume that all MJs are 0 and solve for the one I'm looking for. And that will give you the final. Fixed charge is a very powerful concept, which if you learn how to do it, you will do fine. No solving it. You will just do fine. Ladies and gentlemen, that brings us to the end of the entire Kahoot